Hi everyone, I'm Herman, and I'm going to present my final project for CSCI E-89 Deep Learning class this fall semester. So my project is about credit card fraud detection with an autoencoder. So this is the flows of of my presentation. So we'll talk about the global credit card transaction, project methodology. Then I'm going to explain about the credit card fraud data from the Kaggle, and then we'll do a little bit about the exploratory data analysis. And in this project, I also use logistic regression as a baseline model which I can use later to compare the results with the results of the autoencoders. And then I will show you the results of the training of the autoencoders and finally the testing data result. Okay, that's pretty much about it. So regarding the global credit data, Capital One reported that the total global credit card transaction reached about 680 billion in 2022, and the U.S. total card fraud losses can reach $14 billion by 2024. So the total amount keeps increasing every year. So in this project, we are going to build and train four auto encoders. We are going to train an autoencoder on normal data set and using it to reconstruct the data points. If the reconstruction error is really high, that means the data point is a fraud. Okay. So regarding the project methodology, as I've mentioned before, we are going to use the logistic regression as the baseline model. The logistic regression will only have one input variable, a predictor variable that is most correlated with the response variable. Okay. And then for the autoencoder, I will have four different autoencoders. Its autoencoder basically has a similar structure. The difference is only the number of neurons in its layer. Okay. So model 0, 1, 2, 3 all have similar structure, three-layer encoder and three-layer decoder. The difference is only the number of neurons in each layer. And for the activation function, I'm going to use ReLU. And for its model, we are going to train 20 epochs and batch size is 256. Okay. And for the key performance scores, we are going to use F1 recall precision AUC for the precision recall curve because we are dealing with imbalanced data. For the credit card data, I downloaded from the Kaggle. It has 1 million rows and it has 8 variables, 1 response, and 7 predictor variables. Of the 7 predictor variables, 3 are quantitative and 4 are categorical. Okay. And the data set is imbalanced data. As you can see from the picture on the right, that fraud happens about 9% of the whole data set. Okay. And then based on the quantitative predictor variable analysis, so we are doing EDA right now, based on the quantitative predictor variable analysis, ratio to mean purchase price shows that whenever a fraud happens, there is a very noticeable spike in its histogram. So ratio to median purchase price is the best predictor based on this information. And then based on the categorical binary predictor variable analysis, we can see that credit card fraud happens more with repeat retailer, more on the online transaction, and occur more with credit cards that don't have chip or PIN numbers. Okay. Based on the correlation matrix, we see from the matrix displayed here that ratio to median purchase price has the highest correlation with fraud at positive 0.4623. Okay. Okay. Now I will explain a little bit about the logistic regression. as I mentioned before, I will use it as the baseline model, something that we can compare the results with the results of the autoencoders. Okay, so this is how I build the simple logistic regression. It only has one variable, predictive variable, which is the ratio to median purchase price, because it has the highest correlation with fraud. And based on the graph before, it has really spiked. It has a clear spike when a fraud occurs. Okay, and for this one, for this project, since we are dealing with imbalanced data, we are going to focus on the precision recall curve shown on the bottom right. Okay. And then next thing, we are ready to build our autoencoders. But before we build the autoencoders, we are going to pre-process the original data set. Okay. So we are going to do scaling first. We are going to scale the original credit card data set, and then we are going to split it into test data set and non-test data set. And then we are going only to use the normal non-fraud data. And then we're going to split again into train data set and validation data set. Those two data sets, we're going to train and validate our autoencoder. So this is an example how I built the autoencoder for the model 2. Okay, so you can see yourself, it's a very simple autoencoder model. It has 3-layer encoder and 3-layer decoder, and then the output layer. Okay, and we're going to use the ReLU and sigmoid. And then for the loss and optimizer parameters, we're going to mean square error and ADAM. Okay. And this is the result of training the autoencoders. This is the first model. You can see yourself the training results here. Okay. And this is the second model. This is the third model. And this is the fourth model. Okay. So before I explain about the final result, let's see the Python notebook. Okay. Okay, so this is my Python notebook. So first thing we are going to import some Python packages right here. Okay, and then we are going to load the data set from the Kaggle. It has 1 million rows. So as you can see, after I load it, I display the information about the data frame. It has 1 million rows. And this is just the description of the variables. And next, we are going to do the EDA. So based on the EDA, based on the first EDA, we will. I'm checking if there's missing values, but there's no missing values, so we are safe. Okay. And then we are going to observe the data itself. I want to see how many percent are frauds. So it turns out that fraud only happen 9% of the time. Okay. And then next thing is for the quantitative predictor variables, only 3 quantitative variables: distance from home, distance from last transaction, and ratio to median purchase price. We can see that the correlation among these quantitative numerical variables are really, really low. So meaning there's no evidence of multicollinearity among these quantitative variables. Okay. And then regarding the whole predictor correlation with the fraud response variable, we can see that the ratio to median purchase price again has the highest correlation with fraud at 0.4623. This is, as I've shown you before, during the slide presentation. This is I've shown you previously, okay? And this is next, I'm ready to build a simple logistic regression. I've shown you also this previously, okay? This is how we uh, graph the ROC curve and the precision recall curve for the logistic regression. And next, we do the pre-processing data set for the autoencoders. This is the step, okay? And next, we are going to build the 4 different autoencoders. We have 4 different autoencoders in this project. So this is the first model, okay? And this is how I train the first model. And this is how I graph the loss and the accuracy values, okay? And this is the next few lines are to build the reconstruction error data frame. And then finally, I calculate the F1 recall precision accuracy scores. And then we repeat the same whole process for building the next 3 autoencoders, okay? And this is the result of training for the second model. This is the result of the training of the third model. And finally, this is the result of training of the fourth model, okay? And lastly, let's go back to our presentation again. So based on the testing with the real data test data set, we find that model 2, the one in the blue box, is the best model because it has a very decent F1 score, recall score, and precision score, and also high accuracy score, much better than the results of the baseline logistic regression. Okay. And then lastly, we also have one more measurement, key measurement. So if we focus on the precision recall curve shown here, we can see that model 2 has the best AUCs among the different autoencoders, and model 2, the one in the blue box, also has a higher AUC compared to that of the logistic regression. So that's why for the final step, final decision, I decide that model 2 is the best model for this project. Okay, and for conclusion, the best model again is the model number 2. Okay, and lesson learned is training autoencoder is a little different from what we do when we train other machine learning models. For an autoencoder to detect any anomalies, we must train the autoencoder on only normal, no anomalies dataset. Okay, for this reason, no data balancing is required for autoencoder training. And lesson learned number 2 is I find that adding more neurons in the encoder or decoder layers do not necessarily improve an autoencoder performance. So the pros and cons for using autoencoder is as we add the complexity of our layer by adding more and more neurons or layers, it can get the model can get complicated and not easy. It's very hard to explain to end users. While if we can get like a simple logistic regression to show to end user, I think they will understand it more quickly. And that's all. And then for imbalanced data, we need to focus on the F1 precision recall and the AUC for precision recall curve. Okay. Thank you so much for your attention, and I hope you like the project. Thank you.